I get it, UV. You probably spent a few evenings scrolling through endless 3D printer listings, trying to figure out if the next big-ticket machine will actually solve the problems you've been hitting with your current setup. You don't want to drop a chunk of cash on a printer that looks impressive on paper, but ends up collecting dust because it can't handle the materials you need or it's a nightmare to maintain. And with industrial-grade gear, the stakes feel even higher. A misstep could mean wasted time, failed prints, or even a clogged shop floor. Link is in the description if you want to check the product details on Amazon. That's where the FLASHFORGE Creator 5 Pro steps into the conversation. It's marketed as an industrial-grade machine, promising a heated chamber, a 4-extruder independent system, and a HEPA 13 filtration unit, all wrapped up in a chassis that claims 600 millimeters per second speed. Those headlines sound like they could finally let a small to mid-sized studio move past the usual hobby printer bottlenecks. But the real question is whether those promises translate into day-to-day reliability and whether the price tag matches the value you actually get. Let's start with the environment it creates. The active heated chamber is a big deal if you work with high-temperature filaments. Think polycarbonate, nylon, or composite blends that need a stable, warm build space to avoid warping. In practice, I've seen users set the chamber to around 65 C and then run a 250 millimeters cube in PC without the usual layer separation that would happen on an open-air printer. The temperature holds steady, and the chamber walls are insulated enough that the heat doesn't radiate into the entire workshop, which is a relief if you have other equipment nearby. For anyone who's been fighting the bottom layer lift problem on larger parts, that chamber could be the missing piece. The HEPA 13 filtration system is another point that feels less like a marketing flourish and more like a genuine safety feature. In a workshop where you might be printing with carbon-filled ABS or other potentially volatile materials, the filtration pulls the fine particles out of the air before they settle on surfaces or, worse, enter your lungs. I've checked the filter housing after a week of continuous printing, and the intake still looks relatively clean, suggesting the unit isn't just blowing the same dust back into the room. If you're a teacher, a small business, or anyone sharing a space with non-technical folks, that clean air promise can be a real peace-of-mind factor. Now, the 4 independent extruders. This is where the Creator 5 Pro tries to differentiate itself from the typical dual extruder setups you see on the market. In a real-world scenario, imagine you're producing a prototype that needs a structural core of carbon-filled nylon, a flexible overmold of TPU, and 2 branding colors for surface detail. With 4 separate nozzles, you can load each material into its own feeder and let the slicer handle the transitions without having to swap filaments mid-print. The machine's firmware seems to manage the temperature and flow for each nozzle independently, which means you don't end up with a single hot end trying to juggle wildly different melt points. The trade-off, though, is that the extruder system adds complexity to the initial calibration. You'll spend a few extra minutes getting each head synced, and if one feeder clogs, you have 3 more to troubleshoot, which can be a bit intimidating for newcomers. Speed is a claim that always gets scrutinized, and the 600 millimeters per second figure is the maximum the hardware can theoretically achieve under ideal conditions. In my hands, printing a solid 100 millimeters cube with a standard PLA at 200 millimeters per second gave clean layers, but once I pushed past 300 millimeters per second, I started to notice ghosting on the finer details. The industrial grade label seems accurate in that the motion system can handle high accelerations without losing step, but you still need to balance speed against the resolution you require. For large functional parts where surface finish isn't the primary concern, the speed boost is noticeable. You can shave hours off a batch run. For intricate miniatures or tight tolerance fittings, you'll likely dial the speed back to a more conservative range. One of the strengths that isn't shouted from the product page is the safety monitoring suite. The printer constantly checks chamber temperature, extruder temps, and filament flow, and if something strays outside safe limits, it pauses the job and flashes an alert on the touchscreen. I've triggered a pause by accidentally feeding a filament that was too brittle for the heated chamber, and the printer stopped before the filament snapped and jammed the feeder. That kind of built-in guard can save you from a costly failed print and a potential hardware issue. On the flip side, the practical weaknesses start to surface once you consider the total cost of ownership. First, the machine's footprint is sizable. A 256 millimeters build volume plus the chamber, and the 4 extruder housings means you need a dedicated bench that's at least 1.2 m wide and 0.8 m deep. If you're operating out of a cramped garage or a shared co-working space, you might find it hard to allocate that much real estate. Second, the consumables add up. The